Hello students. In today's video lesson, we're going to be talking about multiplying two binomials together. For today's video, they're just going to be linear binomials, meaning it's just going to look sort of like a linear equation, y equals mx plus b. Okay, so no x squareds, no x's and y's, no double variables, that kind of thing. We're just going to be looking at multiplying two linear binomials together. And we'll talk about a couple different methods to do that. We did briefly mention this before we left our time together last week, Wednesday. So you might recognize a little bit of this, but we'll go through it again. And we'll show you the different strategies that you can use to multiply two binomials together. So if we take this example here, we have the binomial 2x plus 4 being multiplied by the binomial 3x minus 7. Okay, so remember, two sets of parentheses next to each other does imply multiplication. You could, in theory, also see the dot in between them or whatever, but generally we don't see that when we multiply binomials. Normally we see them in parentheses. So what I need to do is I need to multiply this binomial by this binomial and come up with what turns out to be a different looking polynomial as an answer. Okay, so the first way that we can do this is what I call the double distributive property. Distributive property. Okay, the double distributive property, and that is exactly what it sounds like. It's doing the distributive property, but doing it twice in the same problem. Okay, so in this particular case, what we do is we distribute the 2x to both of the pieces in the other set of parentheses. So times the 3x and times the minus 7. And then we do exactly the same thing with this positive 4. Okay, we do the positive 4 times the 3x and also times the minus 7. Okay, so it's a double distributive property, and we actually come out with 4 pieces that we can then hopefully combine the two in the middle. Okay, so we're looking for 4 pieces, and then hopefully we can see that we can combine the two in the middle because they will be like terms. All right, so the first thing that I'm going to do is I'm going to do 2x multiplied by 3x. Okay, so I'm going to do 2x multiplied by 3x. And that, we should recognize this sort of from beginning of chapter 7, but it's a very basic example. Remember that when we have, in this case, 4 pieces, right, a 2, an x, a 3, another x, multiplied together, we are allowed to multiply the numbers. So 2 times 3 makes 6. And then we can multiply the variables, and we can combine their exponents. And we think of their exponents as both being a little 1. So what we end up with then is 6, and then our variable is x with a 2 as its exponent. Okay, so 6x squared. So that's the first part of the distributing 2x. I also need to distribute the 2x to a minus 7. It is important to keep the minus and plus signs on these numbers, okay, or on anything that you're multiplying, because that can affect your answer. So in this case, 2x times a minus 7. 2 times a minus 7 makes a minus 14 or negative 14. There's still an x there, and that doesn't get multiplied by anything else. So it's minus 14x. Okay, so then the next thing that I'm going to do is now I'm going to start distributing this plus 4 to both of these pieces. So my first distribution of that is going to be a positive 4 times a 3x. Okay, so a positive 4 times a 3x. And positive 4 times 3 makes 12. The x is just going to stay there. I should have put an equal sign between them. Okay, so I get 12x when I do that. And then the last thing that I'm doing is I'm going to do a positive 4 times a negative 7. Okay, a positive 4 times negative 7. Now this is just numbers. Positive 4 times negative 7. Positive times negative makes a negative, and the answer is 28, negative 28. Okay, so I end up with these 4 pieces from this double distributive property that I've just done here, and I'm just going to put these together in a polynomial. okay? So each of these 4 pieces, they're going to get added together. So it's going to be 6x squared, okay, 6x squared. Then I'm going to add a negative 14x, okay, and then I'm going to add a 12x, and then I'm going to add a negative 28. Now, when I write my final answer, I will probably change this plus negative stuff to be minus signs instead of plus negative numbers. But that's sort of optional. It certainly would be correct to leave it plus negative answers. Now, the thing I want you to notice here is that these 2 pieces right here, they are like terms. Okay, they have exactly the same variable pieces. They both just have an x. They're not like terms with this front piece because this is an x squared. That's not the same thing. But an x and an x, these are like terms. So I can go ahead and add these together, combine them together. A negative 14x plus a 12x, right? So we have negative 14x. We add 12 to it. That leaves me with negative 1. Negative 2. Sorry about that. Negative 2x. Negative 14 plus 12 leaves me with negative 2x. And like I said, I'm going to leave that sort of as a minus sign here. In the front of that, I still have this 6x squared piece. And then at the end, I still have this plus negative 28, which, as I mentioned, I'm going to change to minus 28. Okay? So I have 6x squared minus 2x minus 28. This polynomial, which we would classify, by the way, as a quadratic trinomial, quadratic because it's degree 2, right? And trinomial because it has 3 terms. So quadratic because of this exponent here, trinomial because there's 3 pieces. This quadratic trinomial is what I get, my product, my answer, when I multiply together these 2 binomials, okay? That's the double distributive property. Now, I'm going to go back. I'm going to erase a bunch of this stuff, and then I'm going to show you the other method, which is called the FOIL method, which is basically exactly the same thing. It's just a slightly different way to think about things, okay? So I want you guys to keep all of that in your brain. Obviously, if you miss something, you can always go back and write it down again. But I'm going to delete all of that stuff, and I'm going to delete these guys as well. Whoops, didn't mean to delete that. That's all right. I can write it back in here. So we had 2x plus 4 times 3x minus 7. Okay, that's what I'm trying to do. And now I'm going to use something called the FOIL method. Okay, now FOIL is all capitalization because it is an acronym. Okay, FOIL, the F stands for first. The O stands for outside. The I stands for inside. And then the L stands for last. Okay, so first, outside, inside, last. And when I draw these arrows, it's going to look very, very similar to what I did with the double distributive property, but it's just a different way of thinking about how to multiply these together, okay? So when I talk about the first, what I mean is the first piece of each binomial, okay, the first term of each binomial. So it's this one and this one. I'm going to multiply those guys together. 2x times the 3x is going to make 6x squared, right? We just looked at that a minute ago. 2 times 3 is 6. X times x makes x squared. By the way, that is the number one thing that people do wrong when they multiply binomials is they don't put that x squared on there, okay? The outside, when I go to this next part, outside, so I've done the first, okay, I've multiplied those. Now I'm going to do the outside. That means the outside pieces. So the very, very first piece multiplied by the very last piece. Okay, so that's going to be the 2x times the minus 7. That's the outside pieces, okay, the very outside pieces. And 2x times a minus 7 is going to make for me, I believe, minus 14x. Or you could always think of it as plus negative 14x, okay? 2 times negative 7 is negative 14, and there's still the x on there. So I've done the outside. Now the inside is the same idea, but it's going to be the inside 2 pieces. Okay, so I'm going to multiply the inside two pieces. This 4 and this 3x are my inside two pieces. And when I multiply those together, positive 4 times a positive 3 is going to make a plus 12, and there's still an x. And all of this should look very familiar because it's exactly what we just did. Just, again, a different way of thinking about it. So I've multiplied the inside, and now I'm going to multiply the last two pieces. Okay, the last two pieces are the 4, the last piece of this first binomial, multiplied by the last piece of that binomial, 4 times a negative 7, 4 times negative 7. I'm going to add that on here. It's going to be a negative 28. And now this, as I mentioned, should look extremely familiar. We have exactly the same 4 pieces we had before when we were thinking about it as double distributive property. But now we have 4 pieces from the FOIL method. First, outside, inside, last. By the way, I should cross off the last for those of you that are freaking out about it. Okay, so then we have the 2 pieces in the middle again that we can combine, the x's, the like terms here, and we arrive back at exactly the same thing that we had from the double distributive property, 6x squared. It ends up being a minus 2x or plus negative 2x, and then a minus 28. Okay, so we're multiplying 2 binomials together. For now, our answers are always going to look like this: quadratic trinomials, making sure we have an x squared in there from the first 2 pieces. There's going to be 3 terms once we combine the middles. Okay. If you have questions, please reach out to me by email, by phone, or during my Zoom office hours. Otherwise, that's it for today, and we will see you soon.